And speaking of alive and kicking, I wanted to move on to Mars, the oldest rover in the history of the solar system. Opportunity, we just celebrated the 14th anniversary last week of the landing. And this was, yeah, happy birthday anniversary, or Opportunity. The mission was designed to last 90 days, or that was the warranty period, I guess you'd call it. If they got to 90 days, they would consider it a success. So personally, I think they need to shoot for 9,000, but we're over halfway there. It's Martian day 4,985 today. So just a quick recap of what had been going on in this mission, and then I'll bring you up to date on where they are right now. So when they landed on January 24th, 2004, they landed inside a very small crater, accidentally. This was the missions that used airbags, and so they bounced and rolled for at least a kilometer across the surface. And Opportunity ended up in this crater that's probably slightly smaller than this room, and bounced around and came to rest in the bottom of it. And over the course of the 90-day mission, they explored that crater and then drove over to another crater, dipped down inside of that, and then when they looked around and said, we're still active, they decided to go on a road trip. And they went to the next largest crater, which was this one called Victoria. They spent the better part of a year driving around Victoria, looking at the interior. They dipped into it. And then, since they were still alive, they took an even longer road trip and drove to this much larger crater. This is, it's about 20-ish kilometers across. And they've spent about the last 3 years now moving along the rim of this crater. From orbit, there appear to be clay minerals on the rim, and clays get geologists, especially Martian geologists, very excited because you produce them in the presence of water. It's sort of rotting rocks away and turning them into clays. And so that's a good indication that there was water in this region. And so they've been driving slowly along the rim of the crater. This actually is an older slide now. They're sitting down here somewhere. And let me zoom in on the rim. So this is a view from the Mars Reconnaissance Orbiter, a much higher resolution camera. And here's where they are right now. You can barely see these yellow squiggles, so I'll zoom in. So first of all, let me get you oriented. Right here is a valley cutting down from the crater rim into the interior of the crater. And it looks like it could be water ran down this. It's sort of a gully, if you will. They call it Perseverance Valley. And so where they are right now is they've driven down from the rim here down into the crater following this fork of the valley. And so right now they're sitting right there. There's one complication since Opportunity has lasted so long. It's slightly south of the equator, and Mars has a tilt of about 25 degrees on its rotation axis. And so when it is winter time in the southern hemisphere, the sun goes down to the north and gets much lower in the sky. And that's a bad thing if you're a solar-powered spacecraft. So how they've managed to survive all these years, I think this is their 7th Martian winter that they've lasted through. They try to find local slopes, even a rock that they can just drive one wheel up on and point the solar panels northward so that they get a little bit extra sunlight and a little bit of extra power. And so that's what they've done over the last winter. And you can see this is just a perspective view. Here's this valley going down the rim of the crater. This is exaggerated. It looks like they're falling off a cliff, but I think in reality this is about a 15-degree slope. So yeah, it's a decent slope, but not nearly as steep as it looks there. And so there was a big discussion on the valley forks into, there's the North Fork and the South Fork of this valley, which one would be best for them. And ultimately they decided, well, if they hug the north-facing slope here, excuse me, that will help with their power situation. So they've been following the North Fork. And this, you can see, is from the position that Opportunity was in about a month or so ago. And so this is their planned route down into the interior of the crater. And so this is a closer up view of where they are, or where they were about a month ago. And again, you can see here's that South Fork of the valley, here's the North Fork. And this is what it looks like from Opportunity. And so this was this is the north-facing slope of the North Fork. And what they ended up doing was driving to get partially up this slope, and they've been examining the rocks there. There's interesting stuff in the area, but they mostly just move back and forth very minimally. And the good news is the shortest day of the year, or the worst power situation, was October of last year. So now we're slowly moving towards springtime, and the sun is getting higher in the sky each day, so they should be ready to start driving again within a couple of months. And this is just a closer up view of that slope that they've been targeting. And this is a squiggly line plot of the power output of the solar arrays. And so this is watt hours. So 100 watt hours is enough to drive a 100 watt light bulb for an hour. And when the solar panels were completely clear, they would put out something around 800 watt hours in a day. And this is where we've been over the course of the winter. It's gotten down to about 280 or so. And then this was the beginning of winter, and here's where the minimum power was, and it's been slowly climbing. But what happened just overnight is we jumped from 434 to 525, and this dust factor, which is the percent of sunlight actually reaching the solar panels are able to provide power, it went up from about 0.7 to 0.76. And so what has happened in the past is you get a big gust of wind or a dust devil that crosses over the platform with the solar panels, and suddenly you're in Fat City again as far as power goes. So they're not at all worried on their power situation at this point. It allows them to stay awake longer during the daytime. When you get very low on power, typically they'll just wake up in the morning on Mars, listen for commands from the Earth. They may be able to operate for a couple hours. Sometimes they take a nap in the middle of the daytime. Sounds a lot like, siesta time. And they charge the batteries, and then they can do a little bit in the afternoons. But by having this bonus cleaning, that will allow the active periods to increase. And so here's a view of where they've been sitting. And so this is looking down the rest of this Perseverance Valley toward the interior of the the Endeavour crater. So here's the recap. It's day 4985. I'd mentioned the 90 days was the target there. As far as driving, they wanted 1 kilometer, so they've gone 45 times farther than the design mission. And they had hoped for a minimum of 1,000 images, and pretty good record. And it's still, the mechanisms on board seem to be holding up. There's one of the wheels has failed as far as being able to steer it, and so what they do is drive backwards and sort of drag that wheel. The wheel still rotates, it's just they can't steer. So that means they're a little less efficient on driving. Okay, so let's move on to the other rover, Curiosity. It's day 1951 for Curiosity. It landed in August of 2012. So we celebrated the 5th anniversary for Curiosity last summer, and so it's about 5.5 years old at this point. And here's the landing site for Curiosity. This is a much larger crater than Opportunity visited. It's about 150 kilometers across. There's a large mountain in the middle. It's called Mount Sharp. It's a stack of layered sedimentary rocks, and this was the targeted landing site, slightly away from the foothills of Mount Sharp, on a fairly safe, flat area. And this is what Mount Sharp looked like right after they opened their eyes after landing. And this is about 5 kilometers high, so 16,000, 17,000 feet. So it's a pretty decent mountain. And what they've been doing is driving off in this direction to this dark stuff is fairly thick sand dunes, and they wanted to find a portal that they could get through the dunes without worrying about getting stuck. And this is a somewhat closer view of Mount Sharp, but you can see all these wonderful layers. And the instruments on board for Curiosity, it's basically a geochemistry lab, and so it can grab samples, drill into rocks. It's got an X-ray spectrometer, so it can look at the crystalline structure in the rocks. It's got a mass spectrometer. It can measure the atmospheric composition. It can measure the elemental composition of the rocks, and it's looking for evidence of the environment that persisted in this area when a particular layer of rocks was formed. And just like the Grand Canyon on the Earth, you start at the bottom, that's the oldest rocks. As you move up, it gets younger and younger, so it gives you a history of the environment on Mars. And right now they're sort of over in this area. They have yet to actually start climbing the steeper part of the mountain, but they're getting there. So just to orient you, Mount Sharp is down here below the stage. This was their landing site. These are these thick sand dunes, and this is the path they've taken since landing. And right now they're sitting right there. And there's names for each of these stops that they've made. So here's where they're sitting, and this is sort of a topographic map of where they're sitting. So this is called Vera Rubin Ridge, and it looks to be primarily made of hematite, which is an iron sulfate mineral, which is good indication that those rocks, anyway, were formed in the presence of liquid water. And so they've been spending a lot of time on top of this ridge, and this is what it looks like before they drove to the top. It's about 15 meters high, so 50 feet roughly. I mean, it's not an insurmountable mountain, but still they needed to find a path that would let them get to the top. And And so here's what it looks like from the top. They're looking off at the distant rim of Gale Crater. And it's a nice scenic pullout for Curiosity. And I'm going to show you a short video here where they talk about the scenery from the top of Vera Rubin.
When the Curiosity rover climbed a ridge and the skies cleared up during Martian winter, we had the chance to take this amazing panorama, and I'm really glad we did. Curiosity is inside Gale Crater, a huge basin made by an impactor about 3.8 billion years ago. The mountains across the crater floor are actually the northern rim of the crater. They rise over a mile above the rover. It's so clear when we took this image that you can even see a hill outside the crater that is 50 miles away. I love how you can see Peace Vallis, a channel that once held a flowing river, like many others that formed lakes inside Gale Crater. This is also the first time we could look back and see everywhere we've been so far in the mission since landing in 2012. Here's the path we took. After landing, we drove to Yellowknife Bay before we turned southwest through Darwin, Cooperstown, and the Kimberley. The rover studied dark, wind-blown sand at Namib Dune. Curiosity then weaved between the Murray Buttes, checked out Ireson Hill, and made a tricky crossing of the Bagnall Dunes before reaching the ridge where it sits today and caught this amazing view.
Okay, so that's the travel log. So this is an image that was just taken 2 days ago, and looking out at that crater rim that we were just talking about, and here you can see the tire tracks that Curiosity has left getting to the top of this ridge. And so for the time being, they're going to continue studying this ridge. It's got lots of very interesting rocks since they have found the hematite. They're examining the conditions for that, and lots of evidence that this ridge was underwater at some point in its past. So here we go. This actually was the latest selfie that Curiosity took just a couple weeks ago. And off in the distance here is Mount Sharp, where it's actually going to be heading, and there's the rim of the crater. But so recapping here, 1951 days since landing. They've driven 18 kilometers and almost up to 470,000 images. So so far so good on Curiosity as well, other than rocks poking holes in the wheels occasionally. They've had not very much wear and tear on the rover, so they expect it to last a number of years still.